Let's go ahead and get started. Anyway, find the values of 6 trigonometric functions. We just talked about this. This one is the square root of c squared minus a squared. I'm not going to do all 6. I'll do 3 now and I'll do 3 later. So for the first one, I'll just do the sine of theta. Since this is on the coordinate axis, you have to know that the sine is the opposite over the hypotenuse. So you take the opposite side over the hypotenuse. That gives you your ratio. A ratio is a real number. All right? So you'd have the square root c squared minus a squared. In fact, in calculus just yesterday, we opened up the inside front cover, and there's an integral that had c squared minus a squared on it, and they have to know that means the inverse sine of theta for their integral. Yes?
You know those 3 things you gave us yesterday?
No.
Simplified,
Right, the things on your note card.
Yeah, do those for her.
Right, those, right. Okay? The cosine of theta, the adjacent over the hypotenuse. All you have to do is fill out 3 of these. You don't have to do all 6. Just fill out 3 of them for your homework. That's fine. If I ask it for a 5 for 10 or 10 for 10, you just pick out 3 out of the 6. You'll see what I mean in a minute. Sine, cosine would be a over c. Okay, and then tangent of theta would equal the opposite square root of c squared minus a squared all over a. Opposite over adjacent. So on the next problem, you wouldn't do sine, cosine, tangent again. You would do cosecant, secant, and cotangent. Okay? So you're alternating between the sets of 3. All right? That usually works out pretty good. Unless you want to do all 6, that's fine. You can alternate between groups of 3. Okay? Fantastic. Questions on that? Obviously, we're using the acronym SOHCAH TOA. Okay? And by the way, while I'm teaching, if I pause for a moment, it's because I'm thinking of a brain break on the fly. Okay? I'm trying to come up with something interesting. No, not right now. It's time for Kylie Stewart's favorite rendition of a 30, 60, 90 reference triangle. Oh, by the way, you remember what exact values mean? Square roots, fractions, no decimals. Takes calculator out. Okay? So what is x and y, Kylie? Is that the short leg or the long leg x? Yeah, it's 5. It's a short leg. So it's equal to half the hypotenuse. And then y would be what? Kyle? Right, 5 root 3 is the long leg. Just today, across the hall, geometry class was talking about the short leg and the long leg. And the long leg equals the square root of 3 times the short leg. And this the hypotenuse. It equals twice the short leg. All right, very good. Yes? Sure. It's not like you can use it for a test. Okay. There'll be other things you put on there. This one, the other reference triangle, as given to us by E. Right. This would be 2 square roots of 2. Excuse me? Yes, you're right. This will also be 2 square roots of 2. Because you know that the hypotenuse is equal to the square root of 2 times the leg. Well, the leg and the leg. So she took 4, divided it by the square root of 2, and simply rationalized it. Okay? Square root of 2, square root of 2. So you get 2 root 2. Okay? Fantastic. Fewer steps she did it. Thank you. Thank you very much. Moving on. Love the reference triangles. Find the exact values of a trigonometric function with the acute angle theta. This one, again, you can pick 3. Since cosine's already given, all you have to do is come up with sine, and all you have to do is come up with tangent. Okay? We go back to the unit circle. And in the unit circle, we said yesterday that the sine was the y-coordinate and the cosine was the x-coordinate, correct? Okay. Sine of theta and cosine theta, x and y. Now, the hypotenuse can never be negative until I tell you otherwise, correct? Okay. I'm not telling you otherwise yet. That we wait on that. So if the 17 is positive, that means the 8 has to be positive as well. If the 8 is positive, that means x is positive. Okay? And that can happen actually in two places. It can happen in the first quadrant, and it can happen in the fourth quadrant. Okay? But it says it's an acute angle, theta. So what does that mean? The acute angle has to be between 0 and 90, so that means it has to be in which quadrant? It has to be in quadrant 1. If it just said the cosine of theta equaled 8/17, that could be in quadrants 1 or 4. But since it says acute, that seals the deal that it has to be in the first quadrant. So, drawing your reference triangle is just labeling the sides, 8 and 17. 8 is the adjacent side, because theta is always the central angle, and 17 is the hypotenuse. Now you have those, adjacent side, hypotenuse. You use the Pythagorean theorem to find the opposite side, which is 15, okay? Which is equal to the square root of 17 squared minus 8 squared, so it's 15. Now you complete the sine and the tangent. Sine of theta is the opposite of the hypotenuse, and the tangent is opposite over adjacent. Okay? Do you remember the identities we had yesterday? The sine squared plus cosine squared equals 1. Do you really think that 8/17 squared plus 15/17 squared is going to equal 1? Do you honestly really think that? You say it with such confidence, I think we'll go ahead and punch it out. Or a lack of confidence. I love these. Second quit, clear, 8/17, which is what? Is that sine or cosine? So there's cosine squared plus sine squared, and it equals 1. The angle has to be the same. I just used one of your Pythagorean identities. The angle has to be the same. You can't have two different angles in the same identity. Yes?
So if you took the cosine and sine of that, it's going to equal what?
The cosine squared plus sine squared would equal 1. Okay? It doesn't mean cosine plus sine equals 1. Just cosine squared plus sine squared. So, if you did 1 plus tangent squared, 1 plus tangent squared. Is that tangent? 15/8? What does it equal? It does. Math, frac. Is that secant squared? I don't know. Second square root. Second answer. Oh, forgot to fractionalize it. Is that the secant? 17/8. It does work. The ratios and the angle has to be the same. Okay, so 1 plus tangent squared does equal secant squared. Now you can do the same thing for cotangent squared, so on and so forth. Okay? So that's just a quick review of the identities and how to label a triangle. If you're given one piece of information about labeling a triangle, more likely it's 2 quadrants. You have to be given a second piece of information to identify which quadrant you're talking about. For instance, the cosecant of 4 is positive. The cosecant is positive in which quadrants? Which quadrants is the cosecant positive? I call them the powers of Bo Barber. Cosecant, where's it positive at? So what do you do? Everything's positive in the first. X and Y are both positive, right? Excuse me? Cosecant would be the Y value. Very good. It'd be in quadrants 1 and 2. Why is he doing that when it's automatically in the first quadrant? Au contraire, it's not always in the first quadrant. Just in the first couple it is because it says acute. Later on, the word acute will be changed, and you have to figure out which quadrant they're talking about for positive and negative purposes. So, cosecant means I'll go with the secant, and I'll go with the cotangent. You can do all 6 if you like. I usually do 3 at a time. Cosecant is going to be in the first quadrant because it says it's acute. Quadrant 2 is not acute, so I'm going to draw it out. Theta is the central angle. 4 is the hypotenuse. 1 is the opposite side. Oh, because any number can be written over 1 to get a ratio. Okay. Hypotenuse is 4. Opposite side 1 means the adjacent side is what? Square root of what? 15. Very good. It's a pretty thick notebook. Thick. Nice. I think I got it all figured out. It's going to be awesome. Nice! You get to jog this one out too. I'm thinking of the brain break in my head. Thick notebooks, perfect. Oh, a thin one. That could be a problem. That's okay. We can deal with it. Excuse me? What is the secant of theta? Right, 4 over root 15. We all know we rationalize it. So it is 4 root 15 over 15. And then finally the cotangent of theta would be just root 15. You can put it over 1 if you like. Yes. Correct. Well, I cut it in half for you right then and there. Is it time for a brain break or should we keep going? Couple more minutes? Okay. Oh, an advertising sign height. Whatever that means. Added in 1999 and removed in 1999. The highest advertising sign in the world is large letter I, situated at the top of the 73-story First Interstate World Center building in Los Angeles. There you go. Trivia. At a distance of 200 feet from the point directly below the sign, the angle between the ground and the top of the sign, what? Oh, from a point. Sorry. Well, we're going to change our picture just a little bit. "200 feet. The angle between the ground and the top of the sign was 78 degrees, 78.87 degrees. Approximate the height to the top of the sign. What the heck? Yeah, this is 73 stories. Well, it's usually 8 to 10 depending on the architect and the building. That's a strong 8, wouldn't you say? It's not 10, is it? We'll go with 8. How's that? What are we doing? It says it's 73 stories. It doesn't mean like, Toy Story 1, Toy Story 2, Toy Story 3. It actually means 8 feet per floor, I believe. Me? 6 foot, but I'm shrinking every day. 10 feet? I don't think my arm is over 4 or 3 foot long. No, my arm's not 3 foot long. That means I have a 3, 6, 9. I don't think so. I didn't say I could. Maybe it's 9 foot. You want to go with 9?
I thought it was 8.
That's 9. I'd say it's probably a strong 9.
I think this room's taller
9 feet? If Sam can jump off 2 feet and hit it with his head, we call it 9 feet. How's that? I'm kidding. Sam was thinking about it. We'll go, how much you want to go to the story? 9 feet, okay.
So we're making a 150.
9 feet equals 1 story. It's somewhere between 8 and 10 is usually a story.
I think it's
You do now. Jot down in the back behind your right ear. It's 10?
yes.
10 foot per story. Oh, it's a false ceiling. Could be another foot underneath there. Okay. So this is 730 feet. Sounds pretty good to me. No, it says at a distance 200 feet from a point directly below it. At a distance,
The point is directly below the sign, so it's 200 feet from the point directly below the sign.
correct, 200. At a distance directly below the sign. It means we're not ready for law of cosines yet. We have to have a right angle. You're saying this is 200?
From the bottom of the sign, like that. I think it's, but I understand.
73 stories. It's usually anywhere from 8 to 10, usually 10. Well, I too. Tangent of 78.87. During the brain break, I'll look it up. How's that? Equals 730 plus x divided by 200.
What's that between 70 and 87?
A decimal point?
Wait, what is it? 70, 40, 70. Oh, okay.
Oh, because the whole leg is 730 plus x, and the x is the height of the sign. Okay?
Why is it over? Oh, God, never mind.
Opposite over adjacent. And what did you get for your calculation when you did this? 287? 287 feet tall. All right. Oh, I'm going to take this off so I can do, actually I'll do the brain break and I'll look it up.
So are we trying to find this sign, or are we trying to find the whole thing?
Approximate the height of the top of the sign.
Just that?
Just that part. I would say it's 287 feet tall. That's that's almost a 28 story eye, 29 story eye. All right, ready? This is going to be interesting. I've never done it before. Like I said, I just made this up in my head. So, but I was thinking back to being competitive. I'll make a brain break, a competitive brain break. Yes. Oh, what? Who did I get this from? Please, for the purpose of this, you need to join the row with Kylie, Hannah, and Kyle. Who was it? No, you don't. Well, because I think thicker notebooks would be better than thinner notebooks. All right, okay, there you go, good. Now, no, you stay standing up. Stay standing up. Everybody stand up. People will cheat on this. I don't want to hear about the cheaters. I just want to know who won. Okay? So, every row captain, 1, 2, 3, 4, 5, will get their notebook, or they can use the notebook of any member of their row. Nice.
Yeah, mine's BC, though. You should probably look it up.
All right. Ready? You have to start, finish, and then end. These notebooks will travel down the row and back to the row. So you have to, since there's 4 people, you have to do it, go to the back, catch it, send it back up, and come back and catch it again.
What?
Ready? This is how you're going to,
What am I doing?
I'm going to explain it to you. I'd explain her only what to do. Correct. So you don't have to do anything. There's 3 in hers. Nope. All right, ready? You're going to take the notebook, And you're going to, without it touching the ground, if it touches the ground, you have to start over with that person not at the beginning of the row. I'm making this up as I go, as you can tell.
Yeah.
So you have to take the notebook, and you have to go a figure 8 through your legs with the notebook, then pass it to the next person. They have to do a figure 8 around with their legs. Oh, that's what makes it so fun. No. You have to do it like a waiter carrying the bottom of the notebook. So, oh, wait a minute, no practicing. And then you send it back. Everybody does it, and then you send it back up here, and then we'll see who wins. Oh, look at that. One row maximum. Yes. Oh no, you got to do it again. And when you come back the other way, you have to do it in the opposite direction. Right, you have to do it twice. That's why Graham gets to do it 3 times. Start, send it back, and in. You have to do it both directions. One forward, then one backward. Yeah. Yes. Good. 1, 2, oh yeah, 3, 4. Correct. Nice. So you have to do it forwards and backwards. Ready? Like a waiter. On your mark? Yeah, like a waiter. Get set. Go. There you go. Now just pass it to him. Just pass it to him. Well, they cheated. Yeah. There you go. Of course they did. Exactly. Yes. Oh, by the way, you guys cheated really bad, so you don't win anything. You guys did great because you had to go above and beyond. Fantastic. You guys, I think you did all right except for maybe in the back somewhere right there. And I lost track of you guys, so you guys are too confusing. So, yeah, I think this team definitely is up there in the top 3. Top 3, bottom 1, probably in the middle somewhere, and then yeah. So that was good. That was interesting. Oh, it gave me time to look it up. Guess what? No, we did it absolutely right.
What?
It said the overall height was 1,017 feet. Well, we had 730 plus 287. What's that make? Nice.
Oh my gosh. We're gonna have to look at this before or something.
No, we made the problem better. We found the actual height of the sign.
That's what it's asking for, right?
Yep, moving on.
Okay.
What? You need your calculator.
I don't have it.
Well, come up here then.
What?
Come up here. You can borrow mine. There you go. Press the mode button. Sure, why not? It'd be fun.
Get up there.
Mode? What mode do you have to be in? Degrees. Very good. Nice. And then tangent of 282. Good. Correct. Now it says how many decimal places? Well, 4 decimal places. So just cut it off, and you get these 4. 1, 2, 3. Oh, well, yeah, but you got to do cotangent first. Now the question is, how do you do cotangent? No, it's no negative. It's on your note card. 1 divided by the tangent of negative 81. Use the reciprocal identities on your calculator. So take 1. No, you take 1 divided by, no it's not. Inverse is not the same as reciprocal. 1 divided by tangent of negative 81. No buts. I'm in charge, I'm right. Close it off. Hit enter. Perfect. Fantastic.
Oh, it's different.
What is?
I wasn't.
Now how? That's okay. Just move it over closer to you now.
Wait, what do you mean?
No, it's not.
Secant. How would you use secant? 1 divided by cosine?
Can you do it? Can you do -1 of whatever?
Yeah, you can. You can't use inverse secant though. That's the second cosine.
Don't ignore that.
Okay. So it's this one. 4 decimal places. Perfect. And last but certainly not least, go ahead. Sine of 97. See, you can do this while I'm gone. Sine of 97. And drag it over there. Yes! Perfect.
Weird.
Perfect.
Oh, 1 over sine? You use 1 over sine. It's supposed to be sine.
That's okay. It's fine.
Oh, crap.
That's okay. Sine of 97. Wasn't that fun?
You're not allowed to say that word.
I think it's ironic that you corrected her. All right. 0.9925. So use reciprocal identities for your calculator. Use those for degrees and for radians.
What's the inverse one for?
Inverse? That's when you're looking for an angle. We were looking for a ratio.
Oh,
7 secant squared minus 7 tangent squared.
Oh, I did it.
This is the Pythagorean identities.
Equals 7.
I don't know. Does it equal 7 or 0? You don't need a calculator for this. All you need is a pencil. What's the identity for secant squared? It's on your note card. Right?
Where it is 1 plus
1 plus what? Tangent squared. Minus 7 tangent squared. So, I can distribute the 7. 7 plus 7 tangent squared. Minus 7 tangent squared. No, 7. It's right in front of you. I put it on a T. You still missed it. 7.
Wait a second. What?
I know! Identities are the best. What about this one? What do you think it's going to be? 7. They're just changing the angle. That's it. But the angle is still the same. If the angle is the same, you can still do the same thing. Watch very carefully. This is a powerful mathematical move. Some of you will pull it off before you leave this school. I'm going to let theta equal y over 3. That's a powerful move. Okay? You're taking charge of the problem. Now I have 7 secant squared of theta minus 7 tangent squared of theta. What does secant squared equal? 1 plus tangent squared. Okay? And then you get 7 again for your answer. Well, the point is that the angle, even though you change the angle, as long as it's the same, you can use the identity. If this said y over 3 and y over 4, you cannot use the identity because they're different angles. They're the same angle, just written in an awkward way. Yes?
I'm trying to understand it.
Good. Good luck with that.
I mean, I can read it. I'm just trying to. I didn't think I was.
That's fine. You got the same answer, right?
I don't even put.
Yeah, okay. Moving. Oh, look at this! These are awesome. What's wrong?
No.
Trying to figure out how to do what? Oh, excellent. I have no idea. This looks hard. We're Spartans. No retreat, no surrender. We see a problem in front of us? We either solve it or send people out that can solve it. I'm sending out, whose turn is it? Rachel, you're after Bo Barber. What is one thing you know about this problem? No, son. Well, yeah, but I'm just trying to build her confidence up.
Probably has something to do with
You know how you give that rah-rah speech when you're coaching in the locker room? And then you send the team out there, the door closes, and the coach says, we don't have a shot tonight. And then they walk out behind the team. See how that goes? What?
Yeah, what was that, Bo?
1 over sine equals cosecant, right? So 1 over sine squared equals cosecant squared. Good. Or cosecant equals 1 over sine, right?
Yeah.
I think I'm going to go with the 1 over sine. I'm more of a sine cosine type person. Good. Easy is good. I set this up for me to do something special because I always like to do this with these types of problems. Does anybody in the room have any idea what I'm going to do next?
Get rid of the
I'm going to sledge it out with sine squareds. Okay? So I'm going to multiply the top by sine squareds, and I'm going to multiply the bottom by sine squareds. That's great! Did you get the same answer? Did you get? Nice! We'll check them in just a moment.
Got it?
I don't think so.
Yeah.
What can you do with the numerator? Factor what? Sine out. So I think we'll get the same thing, Bo. Won't we? We won't? So the answer is sine. No matter how you look at it, if you end up with 1 over cosecant, that'd still be sine.
All that and
I know, that's the great thing about trig. You can work, and it turns out the same as something else.
that sounds
Because of all the identities. Easy? We're not about easy. We're about understanding and moving on. We will get the most of every day, not the least.
yeah.
Ha ha! Look at this. Oh, this has some ground rules. You remember the little activity we just did with the brain break? A lot of you violated the rules, like one person who just passed the notebook, who actually did not participate in the figure eights, just simply passed it without. Where it says verify the identity, you're not allowed to cross the equal sign with any type of mathematical operation. You can't multiply to both sides. You can't divide to both sides. You can't add or subtract to both sides. You're restricted to working one side only until it matches exactly the side you're not working with. If you choose the left side, you work it out until it matches the beginning of the right. If you choose the right side, you work it out until it looks exactly like the left side. Yes, there's always a good choice and bad choice. And yes, some of you will always make the bad choice. There is no easy. I always pick the most complicated side and work towards the easiest side. Why? You have more options. So I will choose the left. I will choose the right. Go ahead. I'll meet you somewhere in the middle. We'll both get the same answer. The answer is given in the problem. The answer are the steps. This is what I mean by a proof. Only statements, no reasons. Your reasons are from your note card. You're going to the reciprocal, the Pythagorean, and the quotient identities to solve these problems. It's like a miniature toolbox from geometry. So cosine squared minus sine squared. Which one of these will I change on the left to match the one on the right? The sine squared. How can I change sine squared? What does it equal?
1 minus cosine.
Very good. It equals 1 minus cosine squared. And the angle stays the same. So I have cosine squared 2 theta minus 1 plus. Nice. Some people take a lot more steps than others. If I give you a quiz or a homework check and you complete the identity in a step shorter than mine, you'll lose a point. If you complete the identity in a step longer than mine, I will not take away a point. Why? It prevents people from just writing this, oh, and then they write the answer. Yeah, it is. So it prevents people from going from here to here. Now, I would do this in one step. I probably would omit this step if I was doing it on my own. I can see the negative being carried through, okay? But if it takes me 8 steps to do identity, and you do it in 2, I don't think so. You understand? That's great! There is no answer to this question. The answer is the work. 5 minutes. We aren't done. I did an identity one time. It took up the entire backboard of my room. I gave it as extra credit. I left that up there for a week. Do you think they'd ever turn their head and look to see the answer to the extra credit? No. They said they kept every day they come in. The identity is impossible. And I was looking through them at the. I said, no, it's not. Yes, it is. No, it's not. They never once saw it on the back because I had to write really small to fit it all in there. I had to multiply. One of the key moves was multiplying by the conjugate of a cubic polynomial involving squared trig functions. Whoa! I think I'll bring that one out. If I knew how to stencil, I probably would.
That'd be really nice.
It would. Which side do you want to choose, left or right? Excellent choice. One thing about identities is you kind of have to think of things backwards than what you're used to seeing them. Here you see a quotient. Here you don't see a quotient, you see 2 terms. Is there any way to write the left into 2 terms? Yeah? Yeah, just change it to 2 fractions. Each one gets the same denominator. Oh, what? Who? Excellent. What is 1 over sine squared? It's cosecant squared. Very good. What is cosine squared over sine squared? It is cotangent squared. Very good. Am I done? No. Which one must change? Yeah. Do you have an identity for that? Very good. It is cosecant squared minus 1. Now I have a match. Now I'm done. Some people will try to like hop, skip their way through these. No. You have to have every step supported by something. Some people will go from here directly to the answer. When I call them out, psh, I know how to do it. I just feel like writing it all in there. Feel like writing it all in there and you'll be fine. Those are great problems. Those are the best trig problems there are. Identities. These single problems get you ready for calculus, the fun of it. I think we're about done. We have 1 minute? All right, so we get to 73. All you do is graph this one out, -8, -15, and you're on your way. Oh, yeah, just do 3 of them. It says 6. Okay? So 73 or 75, something like that. 15 through 75. You're only doing half of them, so that's not bad. Do all the identities, and then we'll talk about tomorrow. This was great. Had the brain breaks.